Section 8.6, Solving Rational Equations. This is the last section in Chapter 8. So here's a type of rational equation that you've had to solve before. We have one fraction equal to another fraction, and when it's set up like this, you can just cross multiply. 3 times that x minus 7, 5x times that 2. We get this, distribute in, and solve it out. Okay, we can only solve using this method when we have two fractions separated by an equal sign. Now, if we compare that last one to something like this, we can see that the setup for this one is different. We don't have one fraction equals to another, so we can't cross multiply in this. So instead, what we want to do is we want to find the least common multiple for all of these fractions. We're going to look just at our denominators. We have a 2 and an x. We want a least common multiple for those two denominators. We can turn them both into a 2x by giving each denominator what it's missing. Once we know that, we're going to take our whole fraction and we're just going to multiply it by that least common multiple. Okay, so that 2x gets multiplied into everything. When we do that, it's going to cancel things out. So for example, this 2 on the bottom is going to cancel with that 2, and we're going to have a 7x. Okay, start fresh with another 2x. When we multiply these ones, this time the x's would cancel. Okay, we'd have that 2 times the 3 gives us a 6. And then when we do the last one here, 3 times 2x, nothing cancels, so it's just 6x. This gives us our equation, and at this point, it's easy to solve. And that's the basic idea. Sometimes they're a little more complicated like this one, where we're looking for the least common multiple of a 2 and an x minus 1, but it's still the same thing. We're giving each fraction, each denominator, what it's missing from the other one. As a first step for these, you always want to factor all the denominators because that's going to make it easier for us to see exactly what's missing from each fraction. Once we have that least common multiple, we want to take that and we want to multiply it into the whole fraction. And this is always going to result in all these fractions disappearing because the denominator cancels out with one part of this least common multiple. So left over, we'd have the 3 times the x minus 1. Then we do this next one here. This time the x minus 1 would cancel. We have the 4 times the 2 left over, etc., etc. This gives us an equation without any fractions, and then we can distribute it out and solve it. Last example, least common multiple, 2x times x plus 1. Multiply the whole fraction by that least common multiple. Everything on the bottom is going to cancel out. X plus 1 times, 3x times that 2x that's left over. Okay, then we're going to have the minus 5 times x plus 1. Okay, and the same thing with a 3 times that x plus 1. Distribute. Move everything to one side. This is an earmuff problem, but before we earmuff, I see that there's a GCF. I can take a 2 out of all these numbers. So I'm going to do that just to make it a little easier. Now we have blank times blank equals negative 12. Adds to negative 4. This is going to be negative 6, positive 2. And remember that when we have this coefficient out front, this 3 here, we have to do the fractions. So 3x over negative 6, we can simplify this one. X over negative 2. This one we can't simplify, it's just going to stay the same. So our parentheses, x minus 2, 3x plus 2. We have that GCF up front. We're solving it because it's equal to 0. This we can't solve. Just set each of these parentheses equal to 0 to get our answers.